So this problem says how much is the pH of a solution containing 0.06 times 10 to the 14 OH ions in 100 milliliters. When you're dealing with pH and concentration of ions or molarity of your H plus or your OH minus ions, just in general, I like to use a little map that if we start out with pH, we can get from between pH and pOH, we can find the relationship between pH and pOH is that pH plus pOH is equal to 14. So if we know pOH, we can get to pH, and vice versa. If we know pH, we can get to pOH as well. Another relationship that we know is relationship between pH and H plus concentration, which is that pH is equal to the negative log of the H plus concentration in molarity. Also, if we wanted to find pH, if we have the concentration of H plus ions, we can find pH. But here we're talking about OH minus ions. So OH minus ions, there's a relationship between the concentration of H plus and OH minus ions that says that the concentration of H plus ions times the concentration of OH minus ions is equal to 1 times 10 to the negative 14. So we have this relationship between OH minus ions concentration and the H plus ion concentration. Also, we have a relationship between pOH and OH minus that's very similar to the pH and H plus concentration. You just substitute, instead of H, you substitute OH, and it's pOH is equal to the negative log of the concentration of OH minus ions. Okay, so we have information about OH minus ions, and we're trying to get to pH. So this is going to be a two-step problem. We can either find the concentration of OH minus ions and go to H plus and then to pH, or we can go to pOH and then to pH. So let's first start by finding the molarity of the OH minus ions. We're given 0.06 times 10 to the 14 OH minus ions. So let's first convert that. Let me actually move it down here. Give myself a little more space. Let's first convert that to moles, because molarity is moles of something over liters. So we need to find out, instead of number of ions, we need to find out how many moles that would be. And then we also need to convert the 100 milliliters to liters. So let's start out by putting the number of ions in the denominator so it can cancel, and moles on top. The relationship between number of particles and moles is Avogadro's number. So the number of ions would be 6.022 times 10 to the 23rd ions is equal to 1 mole of those ions. So grabbing my calculator, I do 0.06 times 10 to the power of 14 divided by 6.022 times 10 to the 23rd. Now be careful here to make sure that you're using like an EE button on your calculator, or put parentheses around this number in the denominator. Otherwise, if you don't do that, then your calculator will assume this times 10 to the 23rd is actually on top, which will give you the wrong answer. So that would cancel out the unit of ions, and what I get is 9.96347 times 10 to the power of negative 12 moles of OH minus ions, or of OH minus. Okay, so that gives me my moles. So if I'm wanting to plug this into the molarity formula to find the molarity of my OH minus, I would plug that in on top, 9.96347 times 10 to the negative 12, over, I need to plug in my liters. 100 milliliters, we can convert that to liters. That 100 milliliters, there are 1,000 milliliters in 1 liter. And so that gives us 0.1 liters. So we can put that in the denominator. We have to plug in our solution in liters to find the molarity. So dividing our answer by 0.1 gives us a molarity of 9.96347 times 10 to the negative 11 molar. Okay, so we found our molarity, and now we can plug that in to our OH minus concentration. I'm going to use the strategy of first going to POH. So to find POH first, my POH is equal to the negative log of the OH minus concentration in molarity, which we found to be 9.96347 times 10 to the negative 11. So plugging that into my calculator, the negative log of my previous answer gives me 10.00158 or 159. That is my POH. So now that I've found my POH, I can use my formula of that the pH plus the POH, which we found to be the 10.00159, is equal to 14. Then subtracting the 10 on both sides, I get that pH is equal to 14 minus, which gives me 3.99841. And this problem, to round our answer, we're given, this is technically only one significant digit because the 6 would only have one significant digit. For pH, the rule is that your significant digits only count to the right of the decimal place. So we need one place behind the decimal. So we're rounding to this 9. Since there's a 9 behind it, that would round up to a 0 and would add 1 to the 3 to make a pH of 4.0. And there we go. So if you have any questions, feel free to leave those in the comments. Also, if you'd like to see a homework help problem done on your homework problem, leave that in the comments as well, and I'll get to it as soon as I can. And thanks for watching.